Hi everyone, and welcome to MathSux. This video is going to help you pass the Algebra Common Core Regents. So we're doing this one question at a time. Here is question 21. Given the pattern below, which recursive formula represents the number of triangles in this sequence? So first let's just look at the pattern they gave us here. So notice we have 3 triangles here, and then we have 1, 2, 3, 4, 5 triangles. 1, 2, 3, 4, 5, 6, 7 triangles. 1, 2, 3, 4, 5, 6, 7, 8, 9 triangles. So our pattern is 3, 5, 7, 9. So they gave us triangles to try and confuse us, but let's just think of this as a regular sequence, 3, 5, 7, 9. So now we need to look at recursive formulas that could potentially match this. So a recursive formula takes on a certain form, and it looks something like this: a sub 1, and they give you a number, and then a sub n, and they give you a formula. So right away, numbers 1 and 2 do not apply here because they're not even in recursive formula form. So we could focus our attention right away to choices 3 and 4. So let's look at number 3 first. So what do these numbers mean? A sub 1 equals 2. That always represents the first term. So if 2 represents the first term, that already does not match this 3 here, right? So this is not our answer. So choice 4. So that's obviously our answer by process of elimination, but let's look at why. So we have a sub 1 equals 3, so that's our first term. So check, that works out, right? And then now we have this formula, a sub n equals a sub n minus 1 plus 2. So all this means is we're taking the previous term and then adding 2. So if we do that, so let's write for our second term, a sub 2. That's just the lingo, that's the notation for recursive formulas. So the first term, second term. And now we're taking the previous term, 3, plus 2, which is 5, which we have. How about the third term? We're going to take the previous term value, which is 5, and then add 2, which is 7. And then lastly, we're going to take 7 and then add 2, which is 9, which we get. So we know that that's our answer. I have a video on this also. Please check it out if you're having problems with recursive formulas. So I'm just going to highlight how we did this. See, we're always taking that previous term and then plugging it in. Question 22. Students were asked to write an expression which had a leading coefficient of 3 and a constant term of minus 4. Which response is correct? So we have a leading coefficient of 3. So a leading coefficient, that means it's going to be next to a variable like x and a constant term of minus 4. So a constant has no variable. So this has no variable. And then this it's the leading coefficient. So it's going to be the highest degree variable. So highest degree just means it's going to be, that variable is going to have the highest number exponent. So if we look at the first one, we see that 3 is a load. So 3 is the constant here. So we know that that can't be the answer. If we look at choice 2, if the highest degree is next to 3, that looks good. The constant term is minus 4, which is a lone. That also looks good. But be careful here because notice the coefficient is 3, and this is a minus 3. Just like the constant is minus 4, and this is minus 4, so that checks out. But the coefficient of 3, this should really be positive. So this should be addition. So this is not our answer. So we're very close with this one, but still not quite right. Choice 3. So let's look at this. We have a constant term of 4. We need a minus 4. So that's not our answer. So by process of elimination, we know that we have choice 4, but let's look at why. So our leading coefficient is 3. So it's positive, and it is next to a variable with the highest exponent. So there's another exponent here, but it has a 2. But this has a 4, which is higher. So this is right. And then the constant term of minus 4 right here. That's also right with no variable next to it. So that's our answer. Question 23. Sarah travels on her bicycle at a speed of 22.7 miles per hour. What is Sarah's approximate speed in kilometers per minute? So here we're going to have to do a bit of a conversion. So we have 22.7 miles per 1 hour, and we want it in kilometers per minute. So we're going to have to convert hours to minutes and miles to kilometers. So to do that, let's first convert it to minutes. So for 1 hour, for every hour, there's 60 minutes. And then we're going to do another equation. So that takes care of hours, but we also need kilometers. So this would be on your reference table, I believe. So for this, every mile, there's 1.609 kilometers. So if we plug this in the calculator, so let's plug this in the calculator. So we have 22.7 miles divided by 60 minutes. These hours cancel out. And then we're going to multiply this times 1.609. And then these miles cancel out. And we're left with this number here, 0.6087 kilometers per minute. So the closest thing here is this 0.6 at choice 2, which is our answer. Number 24. Which ordered pair does not fall on the line formed by the other three? So they give us, each choice is a different coordinate point, and they want to know which one stands out. So the best way to do this is to kind of just find the slope of these different coordinates. Find the slope between different pairs and see what is common between most of them. And if one stands out as different, that would be your answer. So let's first let's pair them up. So if we look at 12, 12, and 3, 6. So let's look at these two. So we have 12, 12, and 3, 6. So I just took the ones down here. So let's just find the slope. Remember, the slope is the change in y over the change in x, or the rise over the run. So if we're doing the change, we're just subtracting and always keeping that same order. So we want 12 minus 6 all over 12 minus 3. So 12 minus 6, 6, right? And then 12 minus 3 is 9. And then this can be reduced to 2/3. So that's one potential slope that is common among all these points except for one coordinate point. So just a reminder of what we did. This was choice 2, and this was choice 4. So now let's try another pair. How about 3, 6? So now we're using that same coordinate so we can see if there's a difference. So 3, 6, and 9, 10. Over here, choice 3. X, y. So let's do that same thing where we find the slope, the change in y over the change in x, and keeping that same order, 10 minus 6, and then 9 minus 3. So this gives us 4 over 6, which can be reduced to 2/3. So again, we have the same slopes. So we notice which coordinate points we incorporated. We have 2, we used 4, and we used 3, but we did not use 1. So that means that 1 must be the odd man out. If we were to test out 1 with one of these coordinate points, we would not get 2/3. So that is our answer. So it's definitely a tricky kind of question, but the most important thing here is that you remember how to use slope and the formula and are willing to test things out to find the right answer. So if you're looking for more on this test, check out the playlist in the link below. Thanks for stopping by, and happy calculating. Need more practice? Check out MathSux.org for more questions. Link below. Also, don't forget to subscribe. Happy calculating!